Welcome back to the Scottibyte channel, and this is Scott. So the other day I had a very interesting discussion with one of my subscribers regarding his rather unique use of Nginx Proxy Manager in conjunction with local DNS. And in his case, he was using Nginx Proxy Manager on a CGNAT network, specifically T-Mobile Home Internet. And I thought it was unusual because, of course, you don't have a WAN address, but he wasn't using Nginx Proxy Manager in the conventional way. So reverse proxy with Nginx Proxy Manager generally allows the use of many hosted services behind one IPv4 WAN address, as I explained in my tutorial why you need reverse proxy. And if you don't know what reverse proxy is, you should go back and watch that particular video because this really addresses doing something a little bit more advanced. So hosted services generally require static addresses, and I recommend the use of DHCP address reservations at your router to manage all static addressing. That gives you one place to go off and manage those DHCP addresses and one place where you can back them up from. And I heartily recommend backing those up because you'll want to know where your servers are pointed. So I recommend that your DHCP servers be hosted on your router. So not all routers also support local DNS resolution. And one example would be Ubiquiti UniFi routers. And in my case, I have a UDM Pro, and it does not support local DNS resolution. So there is a way to support a highly functional local DNS in these particular instances. And that solution is Pi-hole. So Pi-hole is one solution that runs on multiple platforms, and my particular instance runs inside of a LXD container. And if you've been following the channel for a while, you know that's probably what you would have expected. So there's a program in Linux that's called DNSMask, ending in a Q, and it is a lightweight, easy to configure DNS forwarder, and it's designed to provide DNS and also optionally DHCP and trivial file transfer protocol services to a small scale network, and it can also provide local DNS services. So Pi-hole is really simply just a GUI that sits on top of DNSMask and acts as a DNS for your network, which forwards DNS lookups to an upstream DNS server, for example, either Cloudflare or Google. So Pi-hole also discards DNS requests for known adware and malware sites, and really when it comes down to it, that's what most users use Pi-hole for, simply to just put the adware and malware sites in a bit bucket so that they don't have to deal with the extra ads and perhaps malware by translating and going to those particular DNS sites. So that's really kind of a basic capability of Pi-hole. But as we're going to learn here, we're going to use Pi-hole for local DNS, and I'll say local DNS with a twist. So we're going to show how you can leverage Nginx Proxy Manager in conjunction with Pi-hole local DNS to provide SSL. So for those of you that are a little bit more visual, we'll go over this diagram before I describe the specific commands. But the way that things normally work is over at your DNS service provider, you have names for services. And I've given an example of 3 names: my web server, my Discourse server, and my Rocket Chat server. So when somebody hits up one of those services, it goes out to my DNS service provider. It translates that address. It knows how to go down to my router. My router has a port forward for ports 80 and 443, which it sends down to my Nginx Proxy Manager. Nginx Proxy Manager knows how to go out and locate these different services on the server they are on inside of my network. So that's basically the function of reverse proxy. So what I'm suggesting here is that either on your router, if you support local DNS, or as we're going to describe here, how you can implement local DNS on Pi-hole, I recommend that you go in and you create two types of addresses. So one type of address may have been one that you had before, which is simply an address, an IP address for whatever the server instance is inside your network. So a Rocket Chat address, the Discourse address, and the web home address in my example. And what those let you do is basically SSH to those server instances, ping them, that sort of thing. But what I'm suggesting is that you also go out and you create subdomain DNS names like chat.scottabyte.com and discussion.scottabyte.com and www.scottabyte.com. But in all three of those situations, instead of pointing to the server, we're pointing to the local address of Nginx Proxy Manager, which is running on the local address. And it will function the same way as though it came in through the router. The difference is if your internet service provider is down, or if you don't have a WAN address, as in the case of CGNAT, this will still work just fine. There is one big glaring caveat in doing all of this, and that is that many of you may have set up Nginx Proxy Manager running at ports other than 80 and 443, and the reason for that might have been that you put your Nginx Proxy Manager on a Docker server where ports 80 and 443 were already being used. So I'm going to recommend that you move your Nginx Proxy Manager onto something like a LXD container where it has a dedicated address and can run at ports 80 and 443, because this process of doing this local resolution is going to require that it is reachable on 80 and 443. Installing Pi-hole is really outside the scope of this video, but here I've headed over to my router, which is a Ubiquiti Unify UDM Pro, and I have gone in here to my network and my DHCP settings, and on your router you should have something similar, and you're going to want to set the first DHCP address to be the address of your Pi-hole. In my case, 172.16.1.6 is the address of my Pi-hole. Then you want to set your secondary DNS and perhaps tertiary DNS to be addresses for things outside your network. In this case, 1.0.0.1 is the address for Cloudflare in the event that my Pi-hole is unreachable. DHCP address reservations are simply fixed addresses that are managed by your DHCP server on your router. So in this particular case, on my Ubiquiti UDM Pro, I've gone down here and said use fixed address, and that fixed address is 192.168.80.229. The way the router knows how to give it the address 192.168.80.229 every time it boots up is by looking at that MAC address for that particular node. And that's what allows me to manage all of my fixed addresses up here. In addition to that, I might point out that the address that you provide here, 192.168.80.229, in my case, does not have to be something within your DHCP scope. It can be any address within your network range, and your router won't reuse it if it's within a DHCP scope. If it's outside a DHCP scope, it just guarantees that every time that node boots up, it gets the same address. So here we are over on my Pi-hole server, and you can see that my block percentage is actually pretty low at 2.8%. Part of the reason for that is because I have many VLANs over here, and all of my IoT runs on a dedicated VLAN, and so it's not addressed by this particular Pi-hole. Anyway, if you look down on the left-hand side and go to local DNS and then go to DNS records, they provide you a little area here where you can go ahead and type in a domain. So if I just want a local node, I'll type in the name test. So if test happened to be at 172.16.1.77, then I would just go ahead and click on add a record, and you'd be able to SSH to test, which would be at 172.16.1.77. Now, if I wanted to host a service, let's just say that test is some kind of a service. I could have test.scottabyte.com, and instead of entering the address for the server, I would enter the address for the Nginx proxy manager, which is 172.16.1.215. And what would happen is that on my local network, when somebody tried to go to https://test.scottabyte.com, they would not go out to my DNS service provider to get that translated. It would instead go directly over to my Nginx proxy manager running locally. It would then determine where it had to go to the test server, and it would also get the SSL certificate directly off of Nginx proxy manager. This has the advantage that you can still reach your service in the event that your internet connection is down. So what do my entries look like on my Pi-hole? Well, as I scroll down here, you can see that I have a list of local DNS domain names. And whenever you see just a name like bnotes or Bitwarden or CryptPad or Desktop or Discourse, those are just servers, and I can SSH over to those particular servers, or I could ping those particular servers. Whenever you see a domain name of like bitwarden.scottabyte.com or chat.scottabyte.com or discussion.scottabyte.com, those are pointed to the internal address of my Nginx proxy manager, which is 172.16.1.215. This has the advantage of the fact that even if my internet service connection is down, I can still access those services because they're going to go directly over to Nginx proxy manager, which in turn will provide an SSL certificate, which is locally cached on the Nginx proxy manager server, Docker container that is, and then it will go ahead and relay the connection to the appropriate node. If I bring up a terminal, we can see how this looks in practice, and I can do an NS lookup of Rocket Chat. And you can see that Rocket Chat is going to point to 192.168.80.229. If I do an NS lookup of the service that I provide out on the internet, which would be chat.scottabyte.com, instead of pointing out to my DNS service provider, it's going to point to the local address here of my Nginx proxy manager, which is 172.16.1.215. So I can also SSH over to Rocket Chat, and it will make the connection directly over to that server and log me in virtue of the fact that the DNS entry has been configured over on the Pi-hole. Due to some other configuration, my desktop machine does not get a DHCP address, although I have a DHCP address reservation set up for it. But the local operating system is unaware of what the DNS servers are that it should use. So in Linux, the way you can get around that is you can go over and edit with a sudo nano /etc/resolve.conf/resolve.conf.d/head. When you enter this file, you can see that my first name server is set up at 172.16.1.6, which is the address of the Pi-hole. My second DNS server setup is for Cloudflare, and the third one is for the Cloudflare secondary server. If I had made any modifications to that file, I could simply reboot and those modifications would be honored. If I didn't want to do that, I could go ahead and do a systemctl restart resolve-conf.service followed by a systemctl restart systemd-resolved d.service, and it would go ahead and update the DNS entries. To see what your current DNS server entry settings are, you can always cat out the /etc/resolve.conf file. And here you can see there's a big glaring warning in the top of this file that says don't edit this file by hand because your changes will be overwritten. And although when we edited the other file, you still see that, that's the proper means of editing this thing. If you edit this file right here, resolve.conf, and you reboot, your changes will be lost. Although it doesn't look any different, when I open a web browser on my local network and I do a chat.scottabyte.com, as opposed to going out to my WAN address, what this is really doing is it's going to go to 172.16.1.215, which is the address of my Nginx proxy manager server, and that's where it's going to perform the lookup and connection to the server as well as the SSL certificate. So here I hit enter, it goes to chat.scottabyte.com, and it pops up and gives me a login screen. Here we are logged into my Rocket Chat server, and this entire DNS resolution took place locally. And what that means is if my internet service connection were down, I would still be able to access my Rocket Chat server, and so would other people that were locally on my network. So as it turns out, this has some pretty great advantages, and I covered Joplin Notes in one of my videos quite a while ago. And this is a Joplin Notes client that's running here locally, but this Joplin Notes client actually points to joplin.scottabyte.com, which is my Joplin server, so I can use my Joplin both inside and outside my network. So in the event of an internet service outage, I could still use my Joplin clients on my desktop machine, on my phone, and my tablets, even though my internet connection would be down, because now the DNS translation for joplin.scottabyte.com is entirely local by pointing to both the Pi-hole DNS server as well as using Nginx Proxy Manager in a local fashion. So in summary, in this tutorial, we discussed how to leverage Pi-hole with NPM to provide local SSL certificates or your local services that can be locally resolved. We also showed how you can use local DNS in Pi-hole for routers which may not support local DNS. This presentation is a follow-on to my tutorials entitled Why You Need Reverse Proxy and Why You Want Cloudflare Zero Trust. And if you haven't seen those, you might want to circle back and take a look at those. So this procedure discussed will even work with CGNAT ISP providers. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.